name is Eduard Hovy. I'm a research professor at Carnegie Mellon University's Language Technologies Institute. And I'm doing a 2-year leave of absence job at DARPA as a program manager. And I'd like to tell you about the natural language work that's been happening and is ongoing now at DARPA. So DARPA has had an interest in language technology and broader for a long, long time. It started even before with speech recognition work, the air traffic system in the 1980s, which now everybody knows the descendant of that. You use it in your cell phone, you use it when you speak to United Airlines, etc. They've also funded aspects of information retrieval, which you now know as Google Web Search, right? Through especially the evaluations at the National Institute of Science and Technology. Machine translation, which everybody uses now online as a matter of course, it had some of its crucial funding in the early days from DARPA, and again in the 1990s when statistical machine learning machine translation started at the IBM group and was grown up to now common use. Question answering and summarization was funded at DARPA in the early 2000s in the WAVES program and others, and now if you remember IBM system that played Jeopardy, the Watson system was a direct outflow of some of that work. Information extraction, which is something I'll be talking about today, and many other language technology applications were supported by DARPA. So people at DARPA are always looking for what's the next interesting thing, what's going to happen that would support, of course, defense and intelligence endeavors to keep the country safe, but also help just general society worldwide. What technologies can we use? So here are some programs that are currently being or have recently completed at DARPA. One of them is called CCU, Cross-Cultural Communication, and that's looking at the nuances, the cultural specific nuances when different cultures speak to one another and how to avoid misunderstandings between somebody from American culture and somebody from, say, Afghan culture or something. The second one, predicting unstated and coming events. In evolving scenarios, sometimes you want to know what you missed or you want to know what's coming, and this Kairos program is trying to learn how to do that. Detecting alternative conflicting accounts. We live in a world full of mis and disinformation and conflicting accounts of things. We need some system to try to put it all together and give us a coherent story and show us the alternatives. Matching subgraphs and scenario templates when you have complicated, large volume input from many sources and you want to try to find combinations of input and match them against templates of things you know. That's a different program. Searching cleverly through, say, scholarly research articles for things like COVID, for specific kinds of results and things, not just using Google, but enhancing that with more knowledge-based search. That's another program. Learning to do information extraction in unknown languages, the Lorelei program, and I'll show you later on, put together technology to very quickly learn how to understand just enough of a language that has never been seen before by any system to just be able to help. And then extracting all kinds of information facets and so on. So generally, the approach, excuse me, is to say, I have information coming in at the left, and it's text, could be speech, could be images, could be video. And for each of them, I have one or more algorithms that incorporates the information coming in and outputs it into some kind of standardized form. I pull out the entities, the things, I pull out the connections between them, the relations, I pull out the events, what happens, the actions, I pull out the sentiment judgments, oh, it's good or bad, what do people say, I pull out the locations, I pull out the times, etc., etc. And all of that gets represented in that diamond-ish thing, that knowledge base in the middle, in some kind of formalized language where ambiguity has been removed, language has been washed out, it's all in one standard kind of formal representation. And after that, you then build further algorithms to do what you want to do. Do you want to do translation? Do you want to look at hotspots where things are happening? Do you want to find alternatives, etc.? So different programs through the decades have addressed different parts of this pipeline, some more here, some more there, and generally there is a growing technology base, which you in NLP Summit know, of course, but you may not know how much of the work you use every day has roots in DARPA funding and DARPA performers, but there is a lot and you may recognize some. So here is sort of a canonical example of going deeper than just the surface. Much of the work that is done today in machine translation and QA is just text-to-text matching through some kind of neural network algorithm. But if you want to go deeper, if you want to create some kind of abstract, more formal language, you need to do something to extract from English or some other language into a formal notation. So typically you have something like this, and you build, say, information extraction, it's called, to say, let me find the who. Who's the people we're talking about? Let me find the what. What are we talking about? You have patterns for each. Let me find the when and the where. Let me find the how, which is a more difficult set of things to discover. Let me find the why, the reasons, the causes, the justifications. That's more difficult. Let me find the opinion, the sentiments, and so on. For each of them, you build a little extraction algorithm, and at the same time on the right, a notation, a formalism that shows you how you can represent the alternative meanings in there. Sometimes you need many, many terms, like a whole ontology, a sort of metadata set of terms. Sometimes you just need a few. For opinion, you need good, bad, neutral, and mixed. When a new language comes in, like Chinese, if it's a translation, say the first one, you run the same algorithms now applied to the other language, and you want the same output. No, you want to be able to say, I get the same output for the same input, even if it's translated. Now I'm not just doing like translation does a string-to-string replacement. I'm actually doing a string-to-internal representation replacement, so I can do reasoning and search and all kinds of things of that internal representation. That's the general paradigm that we are now addressing very strongly in the DARPA programs. In one way or another, we're trying to find these colored boxes on the right and try to find what aspects do we need to learn about. So here's program number 1, Ahida. This is the program that says, let's find alternative interpretations, the disinformation one. In the present, you get all kinds of information coming in, maybe full of disinformation, video, images, metadata, and maybe you run your engines and you read it as a human and you say, well, this one is telling me this, that one's telling me that. I have no idea of the full scope of alternatives, which one is more strongly represented, which one's more weakly. I just read what I can read in the time I have. In Ahida, the idea is let the machine do all the reading, multiple media, convert it all into one big centralized knowledge representation like I just showed you, and then let it discover the alternative hypotheses, we call them, the alternative claims. Somebody says A, and somebody says B, and somebody else says C. And then let it arrange them to me so I can then quickly discover all the alternatives and then decide which ones I like or I dislike and which ones are more prevalent and where they are, etc. So here is an example. It's a very difficult slide, but I'll just quickly go through it. Let's say on the left, we're in Ukraine, and somebody tweets, I see a tank in my yard. Is that a fish tank? Is that a military tank? What kind of tank is it? And let's say other people tweet, somebody sends a photo, and so all this information gets extracted, as I showed, and put into, in the middle where it says TA1 extraction, into the middle zone, where these little sort of molecules of representation come together. If you look at the bottom 2 light blue boxes, one says there's a military tank T-72, that's a kind of tank that Russians use. There's another military tank T-64 that not Russians use, that Ukrainians use. And we don't know which tank is being talked about. Somebody says it's one, somebody says the other. We throw all this into the middle stage called fusion. We throw all the information into one big soup, and we record where it came from. This came from a tweet, that came from somewhere else, this picture, etc., etc. We wire it together, the little colored circles mean where the information comes from. When we've got a lot of this stuff together, now we apply the third algorithms that's called hypothesis generation. We look at all this and we say, can we tease these things apart? Can we say around the hypothesis that it's a T-64 tank, what hangs together? Oh, it's Ukraine. And what around the hypothesis, it's a T-72 tank? Oh, it's Russia. We can present these two alternatives with their little bar charts at the very right of confidence to the reader, and then the reader can decide which one you believe and how you must respond to this. This is a military example, right? But you can see the application in all kinds of domains in many, many different areas. So the new domain that we're now tackling is, of course, COVID. Because COVID is full of mis and disinformation, and everybody, all of society, all of humanity needs to know what's the truth, right? So to move from Ahida into the new Ahida, we define something we call a claim frame. That is two boxes, the two boxes on the right, and when the text comes in, like in the middle box there, BBC wondered if something, Pravda said something, New York Times suspected something. We break those two parts. We break this in what we call the outer frame, that somebody, the speaker, wondered or said or knew or suspected. We take that sort of epistemic value of the certainty and the speaker and the place it's said. And in the inner frame, the bottom one on the right, that's the actual content, the event. And that's what we used to pull out in the old Ahida. And we put them together so that we can build these bigger frames and we can actually begin to understand who's saying this to me and what are they saying and do I agree with them and what's the evidence for them, etc. This is where we're going with Ahida in COVID. That applies also to images. Notice that when you look at these pictures, if you look at the bottom right picture, you can read and you say bombshell as the shots found to cause a huge increase in coronavirus infections. And then a big red arrow across it, meaning this is false news. Or in the middle left, right, you see dangers of a face mask, etc., and then no evidence in red pasted on top, false. Or on the next one, myth unmasked. Or on the right-hand side, you see there somebody says something, and then there's a little badge up there, say FEMA, which is an official government agency for telling you about emergencies and so on. So if you can train, if you can teach your information, your image processing engines, not only to sort of recognize faces and fonts and things, which are what they do now, but to recognize these overlays, these extra pieces of information to say no evidence, false, X, crossover, and to read inside and to say, oh, the truth, the statement about the truth of the internal content, the inner box, is false on the outer box. You put them together. That's what we try to do now, and pushing the connection of image technology and language technology into one internal representation space. To do this, we need to have many, many more terms than typically we use. Any information extraction engine, almost any representation system you use has a metadata schema, a set of terms for the entities you use, the events, or a few hundred, maybe a few thousand. We've now recently started working on something called the DARPA Wikidata Ontology, DWD, that has about 80 million nodes in it. We extract them working with Wikidata from Wikidata itself, and we restructure it and organize it so that we can use this for all our domains. So this is a very interesting move, and I hope that everybody in the future doing NLP will adopt something like this and have a much bigger representation space to work with. Let's look at Kairos, another program. Here we have the typical analyst, you sitting and reading a million stories. You don't know, have I missed something? What's going to happen? What's coming? If you had an engine that can just learn the patterns, learn the schemas, and say, typically this happens first and that happens second, let's say about making bombs, first somebody gets radicalized and angry, and then they learn about weapons, then they get their weapon or make their weapon, and then they attack, they use the weapon. If all the information that comes in could be sorted nicely in there and all the junk can be thrown out, then you can very quickly say, oh, I'm seeing something happen, somebody's making some kind of bomb here, or maybe could be, I need to know about that, and sort of find out what's going on so we can protect ourselves, right? How do you do this? One team goes to Wikipedia, and they automatically analyze the structure of Wikipedia for, say, bombings and casualties and responses, and they pull out the pieces and they build like those little graphs on the right to say, here is the big staging, first this stage, then this stage, and this stage, and within the big staging, here are the little events that tend to happen. They read, let's say, 1 million documents about all kinds of events and things, and then their task is to build a schema library, we call it, a library of these structures that helps us recognize and predict when interesting things happen. So our challenges here are, well, how many schemas are there? How complex are they? How do we organize them inside? What do we use to represent? Also here, we use this big ontology to represent things. You can see why we need to go big. We need to figure out how to represent time and time sequencing and so on. And for this domain also, we're moving now for the phase 2 to disease outbreaks like epidemics, like, for instance, COVID. And here we're working on having several parallel schemas. There is the story of the pathogen, the bug, right? The bug happens on the top left in the box. The pathogen comes into being, it infects people, the medical community acts, businesses affected, etc., etc. Now we can look at the individual schemas for each person, the patient schemas. You, the patient, you get the disease, you get sick, you stop working, you go to the doctor, maybe you get medicine, whatever, you get better, you die. What's the story of the epidemiologist, They hear about the disease, they investigate it all crazy there, they propose what to do about it, they research it and stuff, they propose methods to stop further outbreaks. What is, I don't know, the authority schema, the health provider, the doctor schema, the pathogen schema. There's a whole bunch of interrelated schemas, each of which, each person, each agency does what it does, and they all fold together and connect to at the right place. The task of the engines is to learn this complexity. Now, this is very, very big and complex. So, of course, you may say something simple like a restaurant. A restaurant has the diner schema. You go to eat. There's the waiter schema to bring you the food and bring your order. There's the chef schema. There's the manager schema, etc., etc. Almost anything we do has a bunch of interrelated little patterns and schemas of people relating. So being able to learn this and apply it accurately is really useful and powerful for all kinds of work. Here's another program called Lorelei. This is the system. This program ended. The goal here was to say when an emergency happens, an earthquake, a hurricane, somewhere in a place where the language is hardly written. I've never had any language technology need to build the language there. And suddenly all people need help. And they write to one another in 6 different languages using a script I don't know, using languages that I have no lexicon. How do I deal with it? What do I do? How do I tell people, here's where you must go, here's where the water is not, here's where people are getting sick, etc. Well, there was a 5-year research program to build the language technology, to use the older technology to make it very quickly adaptable to newer languages, using all kinds of related languages and machine learning, and acceleration of machine learning, etc. So there was an exercise in Montenegro in 2019 where these systems were deployed. There was a pretend outbreak of something, and people had to go and very quickly read a social media post they sent, made of almost 1,000 social media posts, and the systems were able to understand 422 of them and give pointers to the supposed relief workers what to do there. So the output of the systems was a little box like this that just says the type, kind of issue, or do we have shelter or medical or crime or terrorism? Where is it? Is it urgent or can it wait? Is it current? Has it finished? Is it coming? Etc. And then all kinds of how popular, how many people talk about it. And it worked in multiple languages, right? So here, for instance, text-speech input in Arabic, and then building little boxes like in the middle where there's a shelter box and then a rescue box and a shelter box and a shelter box. And these then get merged together to say, oh, a lot of people are talking about shelter in Keria County and a few people are talking about rescue in Kengsei region. And this was deployed and is actually quite popular with the military and emergency response teams around the world to say, can we use some technology like this to do this sort of response? Coming to the last one now, supporting healthcare, supporting cross-cultural communication. It is the case that when you put 2 cultures together, often, even though they speak the same language, they miscommunicate because they don't understand the nuances. But if in many cultures in the Middle East, if I say, oh, you have beautiful goats, and that this person says, thank you, you can have them, he doesn't really mean you can have my goats. He's just saying, I'm honored to get your compliment, right? So there are, you need to know this. Otherwise you think, oh, good, he's giving me his goats and you'll take the goats. No. So how do you know this? How do you learn this? The challenge in this program is to actually build systems that can learn when there are miscommunications of nuance, of sort of interpersonal implication, and can warn the speaker to not make mistakes. So this happens, this learning and training and teaching people before they go somewhere, during having a little thing that sits in the ear and listens and telling you, no, don't say this, no, you made a mistake, fix it, right? And after the mission, when you leave, still being able to interpret what people say about you and how to understand it properly in context. This technology doesn't exist today. Even many of the theories of how you understand what people mean and their implications don't exist today. So the technical approach is to go and discover the norms, discover through face recognition, discover voice, intonation patterns and stuff, put all that together in some sort of theories and then to guide people about what to do. So finally, just to summarize again, we're trying to create capabilities to ingest and process text and multiple media into centralized places with deeper representations so that we can infer extra information to help them whether it's interpersonal, cross-cultural information, information about where people's needs are and things, conflicts and disinformation, misinformation, predicting what's going to happen. There's a whole bunch of very interesting things that we're working on now, trying to support the research community to give technology that is published everywhere, that everybody can use, and that you will probably hear about in the next 5 years. That's all from me. Thank you very much.